Welcome back, ladies and gentlemen. So today we're going to continue our discussion on human impacts in the environment and talk about a side effect of pollution. So when we talk about pollution, that can mean a number of things. What we're talking about today is pushing out toxins from chemical processes, from industrial processes, from burning fossil fuels, whatever the case might be. These materials are toxic when they get released into the environment. And the problem is that although we've talked about how energy decreases up a food chain, nutrient availability decreases up the food chain, toxins actually do the opposite. As we move up the food chain, they actually increase in their potency. And this is the idea of biological magnification. So, a lot of pesticides, a lot of herbicides, a lot of runoff from chemical processes that we're doing to make things that we consume in terms of physical materials often are subject to this biological magnification. And we're going to talk about two examples here today that both work in very similar manners. So DDT was a pesticide that was historically used back in the 50s, 60s, 70s. Um, and we started seeing these declines in bald eagle populations, and people started going, what's going on? Why is this happening? And it was eventually linked back to excessive DDT use to the point where not only did we just sort of say, okay, let's reduce it. No, we said this is such a big problem that DDT use got banned. Same thing was occurring in a similar manner with these compounds called PCBs. And both the DDT and the PCB levels work in a very similar way. They get out into the ecosystems, they get leached into the ground, get taken up by things like phytoplankton in our aquatic ecosystems, in plants, and although it's not a huge problem for organisms at the bottom of that food chain, if we look, that ppm, I should say, is parts per million. How much of this compound are we seeing? And in things like the phytoplankton, in this example of the PCBs in these herring galls, it's a relatively low number per organism. But we go up to the next level of the food chain and look, it's increasing in its concentration. So those zooplankton eat the phytoplankton, they take in that PCB, and they sequester some of it into their own tissues. Well, the same thing happens when we go to the next level in the food chain, and that sequestering of that PCB in their tissues increases again in the next level, and it increases again in the next level, and it increases again in the next level. And what was happening both here in these herring gull examples as well as the DDT with the bald eagles is that was having incredibly dramatic impacts on the shells of their eggs. So those eggs are meant to be the next generation, right? They get fertilized, they become the birds of the next generation. Um, and the shell is there as a protective layer. Well, we thin that layer of protection, and it's kind of like having eggs in your kitchen, right? What happens if you don't have a shell on that egg? You get the yolk everywhere, the white everywhere. And the same thing was happening to these bird eggs that were already fertilized. So the thinning of that eggshell made it easier to crack that egg. The embryo inside has no means of being able to survive and continue to grow. And so that's why we were seeing those decreases in their populations, is because those eggs were being cracked, not able to be the offspring for the next generation. And so by sequestering this, what appeared to be relatively minimal amounts being released into the atmosphere had huge effects as it was being bioaccumulated up the food chain.
Let's examine how human actions may impact pond species. For example, if there is improper waste disposal, spilling toxic chemicals into a pond and killing off the algae, it will decrease the number of herbivores. which will then decrease the number of top-level carnivores. In this case, the more toxins you have, the more the herbivore population decreases, which in turn decreases your predator population. Biomagnification is the increase in concentrations of harmful substances in the environment as they pass through successive trophic levels of food chains and food webs. When even larger fish eat those tiny zooplankton feeding fish, the larger fish contain an even greater amount of toxins in their body. By the time top-level predators, like cranes, consume the toxic fish, the crane's body becomes so toxic that their ability to function, reproduce, or live full-length lives may become impaired. In other words, organisms at low trophic levels ingest small amounts of toxins, which magnify as animals on the next trophic level consume those low-level organisms. And this effect will grow with each succeeding trophic level. Bioaccumulation is the increase in concentration of harmful toxins within an organism. For example, if a fish is continually exposed to toxins throughout its lifetime, it may experience chronic poisoning and a shortened lifespan. The impacts of toxins are unique and may impact an organism in very unique ways. It's also important to remember that different toxins impact different elements within an ecosystem. One type of toxin may impact animals directly, while another may have indirect effects through bioaccumulation or biomagnification, killing off top-level predators. The impact of most man-made chemicals are still unknown, particularly the long-term impacts of these chemicals. If we continue putting chemicals into the environment and allow those chemicals to biomagnify, the impact may have extreme effects on humans as well. Our actions, and even our thoughts and words, have an impact on the world around us. It's not enough to discuss the impact of humans on the environment. What's lacking is compassion and the understanding that we are deeply connected to nature. Only when we come to love and respect nature will the planet have any hope of surviving the current 6th mass extinction.